Okay, everybody, let's go ahead and get started with some rational equations. I always start off with this particular example, so go and write this down in your notes. And I always ask, it's a really difficult question, and I always start off with the question of, what does x equal in this equation that's being presented to you right now? Well, if we look at it, just take a look really hard and take a guess as to what x equals. And if you said that x equals 17, you would be correct. So what I'm going to do is I'm going to make some changes to this problem real quick. If I decided to make them both now over 125 instead of before 25, what would x equal now? Well, if you guessed x equals 17, you would still be correct. And if I decided to make it 3125 for both, and you still said that x equals 17, you would be correct. So after this, what I would do is I would then go with a 1 here and a 0 here. And if you're thinking that the answer is something other than 17 now, you would be correct. So what I'm trying to get you guys to see from this is that as long as the denominators of the rational expression or rational equation are the same, then the numerators should also be the same. So now, in this case, x does not equal 17, and I think you guys kind of know where this is going. The way to get x to be 17 again, or for the numerators to just equal each other, we have to make sure that the denominators are the same. Well, how do we do that? It's a good thing we just learned how to find common denominators in the last section. So that's what you guys are going to be responsible for in this section. Let me give you guys an example of a problem. So in this first problem here, we've got x plus 1 over 3 plus x minus 1 over 3 equals 4 over 3. So conveniently, all of our denominators are the same, which means if all the denominators are the same, I can actually disregard the denominators completely and set those numerators equal to each other. And that's what I'm going to do every single time. Once the denominators are made the same, then I can go ahead and disregard them, because if they're equal, then the numerators will equal. Now, if you're wondering why I can do that, it's because what I can do is, since it's an equation, I can multiply everything by 3 and cancel those 3's out anyway. So typically my strategy is to get the denominators to be the same, then disregard them and solve for the numerators. So how do we do that? At this point, it's pretty much an algebra 1 problem, so I can go and cancel out those 1's. 2x equals 4, and then x equals 2. And that's all there is to it. Let's try another one where the denominators are not the same. Alright, in this next problem, we've got denominators not exactly being the same. So, we've got to find a common denominator here. Well, what's the common denominator between 2n, n, and 4n? Well, if you guessed that it was 4n, then you'd be absolutely correct. I'm going to put a 4n here minus 4n here equals 4n here. Go and switch colors here. Again, go back to the rational adding and subtracting that we did last week or earlier this week. What is the 2n missing in order to become a 4n? Well, it's missing a 2. And I also have to do that up top. What's the n missing? Well, it's missing a 4. So I'm going to go and multiply both top and bottom by 4. And what is the right side missing? Well, it's not missing anything, so if I had to multiply by something, I'd multiply it by 1. So what does the new top become of the left? Well, it becomes 6. The new top of this becomes, now careful, I still left this as a minus, so I'm just going to go ahead and call it 4n plus 20. Now again, I kept this thing positive because I have not yet applied my negative yet. And this thing stays a 1. Once I have all the denominators to be the same, I can disregard them and say I have 6 minus, and you want to be careful here, because I'm not subtracting 4n, I'm actually subtracting the whole thing. And that's going to equal 1. So from here, 6 minus 4n minus 20 equals 1. From here, I'm going to go ahead and combine my like terms. I've got 6 minus 20. So what I've got is negative 4n minus 14 equals 1. So from here, I go and do some algebra. Negative 4n equals 15 So n equals negative 15 divided by 4. Now, before we move forward, there is something I forgot to mention about these problems, and that's domain. When I talk about the domain, remember, domain is the set of all things that we can let our variable be. If you look at the original problem here, we've got 3 over 2n, n plus 5 over n, and 1 over 4n. There's one thing that n cannot be, and that's that n cannot equal 0. And that's because if I let n become 0, I've got 4 times 0, 0, and 2 times 0. And if I have a 0 in the denominator, I have something that's undefined. And I will prove to you guys why something divided by 0 is undefined, but not right now. So for now, please just take me on faith that something divided by 0 is undefined. I will show you guys a proof of that later. Alright, let's take a look at another problem. Okay, this next example here. Again, we want common denominators all the way throughout. So I'm looking at x, 6x, and 2x. What's the common denominator here? I'm thinking it's 6x. I hope you agree. And now we've got to find out what's missing from each side. So again, for my left term, I'm missing 6's. For my middle term, I'm missing nothing, so I can technically multiply by a 1. And from my right, I'm missing a 3. Again, I'm trying to make it 6x, right? So my new left becomes a 6. My new middle is exactly the same as my old middle. And then my new right will be 3x plus 15. Once I have my new denominators, I can cross them off if they were all the same. And now I just have to figure out what 6 plus 4x plus 3 equals 3x plus 15 is. Go ahead and solve for x. How do we do that? I'm going to go ahead and combine out those like terms. 4x plus 9 equals 3x plus 15. I'm going to go and subtract 3x from both sides. I get x plus 9 equaling 15, and I've got x equaling, looks like 6. Now again, should have done this beforehand, but I keep forgetting. My domain. What was the domain of the problem? Well, look at the original. X cannot be, looks like 0 yet again. Because if x equaled 0, the problem would be undefined. And I want you guys to establish that before you begin the problem. And the reason why I want you to do it before is because if you end up with 6 or 0, let's say you end up with 0 as the answer for x, that means that your answer is technically no solution, because if you plug in a 0, you're undefined. Okay? So check the domain of each of these. It's kind of a good way to lead you into domain, which we're going to do next week of these anyway. So always be sure to check the domain. Let's try another problem. Next example. You guys knew it was coming. You knew it was going to happen, and it has happened. Before we even find a common denominator, we probably have to factor something. So I'm going to factor before finding that common denominator. And that really is the only other thing that can happen that will make these problems more difficult. So, I'm not going to forget this time. Before we begin, I'm going to establish the domain. The domain is that v cannot equal, looks like 0, right? Because if I let v equal 0, then I'll have a 0 on the bottom. And v also cannot equal negative 3. I want to make sure I keep that in mind. In case I end up with one of those as my answers, I want to make sure that I disregard that answer. Okay? Alright, so now, common denominator. Look at the factored version. Looks like the common denominator is v times v plus 3, right? So, I've got v times v plus 3 as each of my denominators. Now, what was missing from each piece? Well, nothing was missing from here, so this thing will remain a 2. Nothing was missing from the middle, leaving this to be a 1. And a v was missing from the right piece. Once my denominators are all the same, I can say goodbye to them. I have 2 equals 1 minus v. And I can go ahead and just subtract 1 from both sides. I've got 1 equaling negative v, by multiplying both sides by a -1, I get v equals -1. Cross-reference that with my domain, there is no interference, v equals -1 is, in fact, the answer. Let's try the last example. Alright, this is the last example, and again, you guys knew it was coming. I'm going to factor before getting the common denominator. So I got 6 over, looks like b plus 4 and b minus 3 equals 1 over b minus 3 minus 4 over b plus 4, b minus 3. Alright, so what's the common denominator here? Well, it's clearly the b plus 4 and the b minus 3, right? Cool. b plus 4, b minus 3 equals b plus 4, b minus 3 minus b plus 4 and then b minus 3. Now, I almost forgot, I will not forget, the domain. What can't b equal? Well, it looks like b can't equal -4 or +3. If I get one of those, then I have to disregard that answer. Okay, let's figure out what was missing. Well, nothing's missing from the left, so that thing will stay a 6. What was missing from the middle? Well, a b plus 4 was missing from the middle. And nothing was missing from the right, so that can just stay a 4. So, b plus 4 will join the new middle. And now that my denominators are all the same, I can go ahead and disregard them, leaving us with 6 equals b plus 4 minus 4. Well, that's kind of cool. The 4's knock each other out, and you get b equals 6. Does that run interference with the original domain? It does not. So b equals 6 is a solid answer. That's all there is to it, to solving rational equations. Go ahead and get started with the homework, and we will get that passed out to you via a worksheet in just a few minutes. See ya.